Hello students, welcome to class. In this session we will discuss an example based on the DFA. So question is like that: we have to design a deterministic finite automata in which the language will be accepted by it. Okay. So what is the language here? Language M with L. Okay, language L of M is there in through which. So what is the language? Language is the collection of strings. Okay, so how the string is denoted in this question? In this question string is denoted by W. Okay, and what are the elements, or you can say what are the symbols which were accepted in the string? The symbols which were accepted in the strings are A, B, and its star. The star means the DFA has the potential to accept null values. Okay, basically this symbol is for belong to. Null value is represented by like this or lambda. Okay, both have a same meaning in terms of null value for this. Okay, so what the question says? Question says that you have to make the string which does not contain three consecutive b's. Okay, so what are the possible strings which were generated through this string? The possible strings which can be generated are lambda means null value, a, b, a, b, b, a, b, b, a. Okay, you can generate these strings. Along with that you can generate a b, a b, a, and you can also generate b, a, b, 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 a. Okay, but if even you can, even the DFA can accept the string like triple a b or simply triple a, but if any string will contain three continuous b, then it will discard that element. Okay, so you have to develop, even if the DFA will not be able to accept the string if it will be like this a triple b. If this kind of string will be given as an input to the DFA, it will simply discard that. Okay, now and even if the strings will be, if it starts with triple b a, then also the string is going to be discarded. So you have to develop the DFA in such a way that it can accept only those strings in which there is no such continuous consecutive b's. So how you are going to design the DFA? So let me discuss and let me try to design that. Fine. So first of all, what we will do? First of all, we will make an initial state q naught. I will make the diagram little above so that it will be take less space. Q naught, from q naught we are going to start. Okay, now from q naught, what are the possible strings which it can generate? It can generate lambda, a, b, a, b, b, a can be accepted by this, but if b will be there, then it will simply ignore it. Okay, and if a b will be accepted by this, a should be accepted by DFA. Okay, so these are the strings which can be accepted by. So let's make the DFA which can accept at least this kind of strings. So from q naught you have, if you pass, we will discuss about the lambda later on after having few states. Okay, so if we pass a, then what will happen? It will reach to next state. Okay, and if we pass b, then what happen? Then we have to create the new state at the initial position if there is a b. Okay, so in this at a single point there are two different stages were arised. And what about if we want to pass the lambda, then what will be happen? Then how this lambda value will be accepted? For that we have what we do, let me make the diagram once again, transition diagram, that first of all it should accept the lambda. So lambda means whenever we give empty values, during the empty values only it will be, it shows that the string empty value has been accepted. So it means that the things which begin will end at the same moment. So how you represent the state which will be initial as well as final? See, this is how you represent the initial state. Okay, but if you make this double line circle, then this is called initial state, and this is the state where initial and final states were same. Okay, so first of all we have to accept this value, that how lambda is accepting. So if lambda is accepting, so we have to make the initial state to be as a final state first. Okay, this is the initial state, and we have made the initial state as a final state, so that if lambda will become, it will be get accepted. Then if we pass, first of all we have to design such a DFA which will not being able to accept 3 B's, continuous B's. If we'll make this DFA which will not accept 3 B's, then other will automatically get designed. So if we pass B, it will reach to next state. If we pass B, it will get reached to next state. If we pass B, again it will reach to next state. And see, now the thing which we have to understand here is that if we get single B, it should accept, and we know that in a DFA more than one final states were possible. So when we get first B, let we make it a final state so that it will get accepted by the automata. If we get two B's, then also it will get accept. So we have made two B's. But what about three B's? If three B is continuous will be there, we will not make this as a final state, because if we make this final state, then it will be get accepted, which we don't want in our problem statement. So what we have done, we have made the Q0, that is Q0, Q1 and Q2 as the final states, where single B, lambda, single B and double B were get accepted. Now what about if A will be there? If we give A as an input, so what we have done, we have made, if A is single A is there, then we have made the loop on the initial state, so that if A will be passed, it will get accepted. If A will be passed, by making the loop twice it will get accepted. If we pass 3 A's, it will get accepted by 3 A's, first A, second A, third A. Since initial state is final state, so it will be get accepted there. Okay, now if we want to pass A B A, then what will happen? So from here we have passed A B, then what about A? So for this what we have done, what we will do, we will make a transition from Q1 to Q0, and here we pass A. Okay, so that if you pass ABA, then it will be easily get accepted. See how, first it will traverse A, then B, then A, means yeah, this one is now being get accepted, this string is accepted. Now what about if the string will be like ABBA, then how you are going to accept this string? So again for this what we have done, A B B, then for A we reach to the initial state. Is that clear? So what we have done, from this B we have made the state which will be get accepted at this, and we have designed this as a A. Is this clear till now? Okay, fine. Now what happens, now the question arises to you is that, sir, what about this, why we have not connected this q2 with this q1? Okay, so the reason why we have not connected, you will come to know very soon. Fine. Okay, now we have passed these strings. Now what about if string will have, like, if string is there like a triple b a, what will happen? Although the input will get inserted into the automata, but it will not generate output. How? See, first b is there, second b is there, third b is there, and if there is any a, or let me say, let me repeat it again, I will repeat this again. If there is a, so first loop they have cleared, then b, then b, then b. Then if there is a, then we have made the loop here a. But since according to the question we don't want three continuous b's, that's why it may get the input but it will not generate any output. So because there is no such final states are there. Okay, and even after having the a triple b a b, then also the loop will be at the last of the state. Why? Because once the three b's were recognized by the automata, then they were useless, because our automata does not want three consecutive b's in our DFA. So this is how the deterministic finite automata is designed for, how the for designed for the statement which will not be accept three continuous b's. Now you will try to write any string with the help of a and b and check whether those strings were accepted by DFA or not. Okay, and in that try to keep the strings which will include triple b and exclude triple b. In both the statements you will try to get the result that why the q2 is not connected to the q1 while passing the a. Okay, now let me draw the transition table for this. So this is called transition transition diagram. Now let we make the transition table. So how we are going to make the transition table? For transition table, let we write the things in the form of initial state, next will be symbol, and next will be final state. Now what is that initial state? Initial state is suppose q naught. So how we represent a state? We represent a state in the form of q, symbols in the form of sigma, and final states will be transition of q and sigma. Okay, now let's we see the transitions. Suppose we pass q3, sorry, we start with the q naught. If we pass q naught, then symbol will be a, and where it will reach? It will reach to q naught only. If we pass q naught, and from q naught if we give an input as a b, then it will reach to q1. If we give an input at initial state as a q1 and a will be the symbol, then where it will get reach? It will reach to the q1, sorry, q0. Okay, now if we pass q1 and give the input as a b, then where will reach? From q1 if we give b, it will reach to q2. Okay, now if we give, now we are at a q2 state. Now from q2 if we give the input as a, from q2 if we give input as a, then what will happen? It will reach to the statement q, from q2 it will reach to q0. From q2 if we give a, it will reach to q0. Now if from q2 if we give b as the input, we will reach at q3. Now from now from here q3 if we give input as a, where we will reach? We will reach at q3. And from q3 if we give input as a b, we will get reach to the q3 only. So this is how the transition table has been designed. Now the thing which we have to keep in mind is that whenever we write such things, we have to indicate that which is our initial state. So these are our initial state. Now which are final state? Final states were, these are our final state. This is final state. q2 is again final state. These are the final state. Okay, or let me write f in the front of final state so that there will be no such things will be arise. From q1 if we give the b, it will reach to the q2. Okay, so this is the final state, 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 this is again the final state. q3 is not a final state. Okay, these are intermediate states. So this is the transition diagram for this is the transition table of the above transition diagram. So let me write here that this is the transition table. Okay, now let me see what are the elements we have covered in this. The elements which we have used in this were q. Q is the set of states. So how many states are there? q0, q1, q2, q3. There are 4 states were there. Then how many symbols we have used? We have used 2 symbols. These are a and b. How many which final states are there? Final states are either denoted by f or q of f. There are 3 final states. These are q0, q1, q2. How many initial states are there? Initial state is 1, that is q0. Okay, and what about del? Del is the transition function between q and sigma. Okay, q and sigma. So how we represent these things? This transition is denoted here. Okay, so this is the example of DFA where it accepts the input string which will not contain 3 consecutive b's. That's all for the this session. Thank you.